So now we are in the Ableist console, and let's go and type X-Ray to go to the X-Ray console. Now, as you'll notice, I am into the X-Ray and it says get started. What I want you to do just before that, please, is to go to the US East North Virginia region. I haven't had any luck running this tutorial into my region Paris, so maybe it won't work for all the regions, but one region I know where it works is in North Virginia. So let's go to North Virginia, and we are in the X-Ray console, same console. We'll click on get started. Now we get started with X-Ray. It says either we'll launch the sample application or we will instrument your own application. We'll go in the hands-on with the first option, but I want to show you the second option just to show you that everything I taught you is indeed needed. You need to choose one of your programming languages. And so let's just assume Node.js right here and click on next. And so it says, okay, to run your application, you need to add the X-Ray SDK to your application dependencies. So as I said, you could go to any of the languages from before. Java, it will ask you the exact same thing. It says you need to implement and import the X-Ray SDK for Java. So let's go back to Node.js. Basically, step one, import the SDK. Then you need to initialize the SDK, so do some code modification to basically enable X-Ray and so that X-Ray can create segments on your application and so on. Now, once you have done your application modifications for whatever language you're using, Python, Node.js, Java, etc., then the second step is to run the X-Ray daemon. Okay, this is needed, and so it gives you the fact that the X-Ray SDK does not send data traces directly to X-Ray. It's because they want to avoid throttling, and so we need to run a daemon, and the daemon will upload them in batches. And so to do this, it gives us the instruction on how to do it for EC2 Linux, EC2 Windows Server, ECS, Beanstalk, and Lambda. So you get all the instructions right here. One thing I want to show you is that on Linux, it could be EC2, it could be anything else really. It's just a curl to basically download an RPM file and then to install through that RPM file. So I think it is quite easy to enable X-Ray on EC2. The other thing I want to show you is Beanstalk, because I think that can come up at the exam. How do I enable X-Ray on Beanstalk? Well, if you remember, Beanstalk can be extended, and for this we can use EB extensions file. So we'll have a directory at the root of the code called EB extensions, and within it we'll create an X-Ray daemon.config file. And within it, we'll just include these 3 lines of code saying that the X-Ray is enabled. And that's it really, but it's something that can come up at the exam, okay? Elastic Beanstalk needs to have this little EB extension file for it to have the X-Ray integration enabled. Okay, so let's go back because we're going to launch the sample application. Now, the reason I made you go to North Virginia is because the sample application, per my experience, only works in that region for now. Let's click on next. And so say, okay, we're going to launch the sample application. You can click here and this will teleport you to GitHub, and you can see the whole application about how it works. If you're curious about which language it is HTML and JavaScript. And if you can look at the code, you can see it's Node.js and it tells you how it's been implemented. We don't really care about the how, we really care about how it works. So it says to launch the application, we click on launch sample application, and we are into CloudFormation, our good old friend we just saw. And so CloudFormation, this time we'll specify an Amazon S3 URL, click on next, and then we can specify a stack name, X-Ray sample. Now we have to select a subnet. These are parameters. So we'll create this subnet, and we'll select this subnet and select this VPC. Click on next. Here we just scroll down, nothing's to be needed. Click on next. And now we get a little warning here saying the following resources require the IAM role capability. So this CloudFormation template will create an IAM role. Yes, I understand that the CloudFormation may create IAM resources. We're happy with that, and we click on create. Now this goes ahead and launches a whole stack for us. So let's refresh this. And the X-Ray sample stack creation is in progress, which is good. This is what we need. And so if we look at this CloudFormation template, we can see it is YAML, and it's a good time to look at CloudFormation again. So it has 2 parameters. It has the VPC parameter and the subnet parameter. We can see they have different types. The first one is the VPC type, the second one is the subnet type. And then it creates resources. And so for these resources, it creates an IAM role. Then if we scroll down, it creates an IAM policy. And if we scroll down, we see that there's a ref. So there's a reference, interesting function here happening to link the policy to the role. And we can scroll down. So instance profile, IAM role, And then we create a Beanstalk application through this template, and it gets configured, etc., etc. And so as you scroll down, you really understand that there's a lot of things happening, and we get outputs out of it. So outputs is what we're going to be able to see in this little output tab. And we can find the get attribute function right here that we learned from before. So we'll get the endpoint URL from the Elastic Beanstalk environment using get attribute, which is really, really fun and cool. And you can see there's other type of outputs being created. So this, per experience, this stack may take 5-10 minutes to create. So what I'll do is I'll just pause my video and get you back in 5 minutes. So now my CloudFormation template has been completed, and we saw it just launched 2 CloudFormation templates. And so if we look at resources, we can see it created a bunch of stuff in this stack and that stack as well. You can click in the details, but it created a lot of things, as we can see. Anyway, for us, we go to outputs, and the Elastic Beanstalk environment URL is what we're interested into. So we'll go to that URL and we're welcome and say, welcome to Iris X-Ray sample application. Now we click on the start button, and the start button is going to generate signups, up to 10 sign-up per minute. So that means that we get a sign-up every 6 seconds. And here we are at request number 2, and it's just signing up random URLs. So it turns out that, we're going to leave it run for like maybe 20, 30 signups, so about 3 minutes. And so it turns out that each minute there's going to be a duplicate signup. And this duplicate signup should trigger an error, okay? And so we're going to look at these errors into Iris X-Ray and see how things work. So I'll just pause for 2 minutes while we go to request number 30. Now 36 requests have been made. So if I go back to X-Ray and click on done, the service map is getting computed, and we should see in a second that we have our whole map of the calls being made. And so we can see that as a client, I'm talking straight to my EC2 instance, which is my front-end development instance. And the instance is making calls to 169.254, 169.254, which is the metadata service from AWS. It's also making calls to an AWS DynamoDB table and making call to AWS SNS for notifications. We can get metrics around the number of calls per second. So we get 7 calls per minute here, 1 call per minute here, 7 calls per minute in DynamoDB, and 6 calls per minute in SNS. So this sounds about right. And so what we can see is that there's errors happening in my front-end dev instance, and they're from, it looks like they're from the DynamoDB table. So let's click on the EC2 instance, and here we can see some really interesting things. We can see that we have a distribution of response time between, lower end 15 milliseconds to maybe 150 milliseconds. But most of our requests are between 50 milliseconds and 100 milliseconds. So if we wanted, we could, trace all the requests only that are a bit slower. Maybe we can even trace the one that is the slowest, right? So you're able to just select and choose whatever you want. So right now, let's say we are interested about the errors, okay? The errors are going to be, orange, the false red, the throttle purple, and the OK green. So we're only interested into the errors, and we click on View Traces. Now we can see the traces that correspond to these errors. We can know it's errors because the top has like a filter saying error equals true. And so we can see there's 2 errors. There is the signup URL that provides us errors, and the favico.ico. So this error was actually triggered when I launched the website. It turns out it wasn't able to find an icon, and so we got this little error right here. But the signups is what is being generated by the start button right here. So if we go back, we're interested into the signup. So we'll click on the signup URL, and here we're able to drill down into the traces that do represent errors for the signup. So this signup has triggered a post, and the response was 409, and it took 30 milliseconds to get the response. So let's click on one of those to see what happened. So we can see that the front end basically made a request to DynamoDB, and the post for that request was post signup, but then it made a DynamoDB called put item, and it tried to put an item into that table. So we're getting a lot of information around what happened in the application. And then we got a response status 400 from DynamoDB, which means whatever it means. So this is kind of cool because here we're getting a little bit more information around what goes on in our trace, right? Now let's look at an interesting trace as well, which is going to be a trace of OK responses. So let's look at OK, click on View Traces, and we'll look at the signup OK. and we'll just get a random one. So we get a 201 response, which means okay. Let's click on this one. And so we can see here that there was a request made to DynamoDB and a request made to SNS. So we can see that the 85 milliseconds it took to create our request, 27 milliseconds of which went to DynamoDB and 57 milliseconds of which went to SNS. We can also see that the SNS action was publish. So it's kind of neat because we start seeing a lot of details. Now, if we do even something cooler, let's go to the little metadata instance. Let's click on OK and view traces. And now we're able to view a trace that actually talked to the metadata service. And we can see that the request is getting more and more complex. So there was a DynamoDB call for 69 milliseconds that also was part of getting credentials. You know, here we can see the URL actually asks for security credentials from IAM. So that's the instance role doing its magic right here. And then when it was done, SNS did the exact same thing. And we can see how long it took to talk to the metadata service. And here we could, if we wanted, drill down into each service to get an idea of how things worked. So this distributed tracing thing is really, really cool because we're really able to get graphs and traces and just navigate the errors into our code. So that's what's really, really is awesome about it, X-Ray overall. It was really simple to enable. And then we get this nice service map. So that's it for X-Ray. Just to delete X-Ray, just stop the website and then go back to your CloudFormation. And we know CloudFormation now. We'll just click on X-Ray sample and click on delete stack. Yes, delete, and we're done. So that's it for X-Ray. I hope you enjoyed it, and I will see you in the next lecture.